These are the frequently asked questions for Algebra 2 for section 6-8, day 1. I'm going to start with number 9 here, and you probably don't really need this one, but just in case. We have y equals the square root of x, and then minus 4. So we think about our y equals a square roots of x minus h plus k. And we realize that what we're looking at here is just a basic graph of y equals the square root of x. But then we have that minus 4, and the k of negative 4 means we're going to move that 4 units down. So we start by just graphing the parent function, and as we did in class, we just want that classic table, that generic table that we always use. The smallest number that we can use and still stay in the real number system is going to be 0, and that'll be 0, 0. I don't want to put a 2 in there because then I end up with a nasty little decimal. So I'm going to go ahead and go all the way to 4 so I can get a 2, and 9 so that I can get a 3. So this one I'm going to make dashed because this is not my final graph. Oh my, Smartboard's graphing a little high today, and I actually oriented it just this morning. Alright, so there is my square root curve. And now, that k of negative 4 means that I need to move that entire graph 4 units down. So what I'll do is I'll just take those nice 3 points that I graphed originally and move those 4 units down. That one will be a solid graph right there. So the green one, the solid, is my actual graph. Again, the first one, the dashed one, is just for shape. I want to see what that's going to look like. Then for number 13, this one we realize again is just the graph of y equals the square root of x, but this one has an h of negative 6. So that means I'm going to need to move this one left a negative 6 units. So I'll go ahead and get my sketch from the red table here, just like I did in the last one. So we've got our 0, 0, 4, 2, 9, 3 as our guide for shape. And then I need to move that 6 units to the left. And there we go. So that one I'm getting used to the Smartboard graphing a little bit too high. All right, then the next ones, we're still graphing here, but they're getting a little more involved. So in number 17, I realize, okay, now things are different. You know, I have an a out there of negative 5. So again, I just want to graph the parent function first, which would be y equals negative 5 square roots of x. So I think of my normal table and the numbers that would come out of there. Normally you put a 0 in there and you get a 0. That's going to happen here too, because if I put a 0 in for x and multiply by negative 5, I'm going to get 0. But when I put a 1 in, I normally get a 1. Now it's going to be 1 times negative 5. So things are going to be below the x-axis. I put a 4 in there, I'd get 2, and 2 times negative 5 is negative 10, and that's probably all I'm going to need here. I could certainly do the next one. The square root of 9 is 3. 3 times negative 5 is negative 15, but that one I've got my negative 10 to 10 standard window here, so I'm not really going to need that one. So there's my parent function, and again, that's not the final graph, but this gives us a really good idea. I'm going to move this up so you can see those negatives of what's going on with the graph. So that negative 5 has really stretched this out, like so. So there's the shape. And now I go back up and take a look at any h or k values, and I realize that in this one, h would be a negative 2, which means I need to move this thing 2 units to the left. So I'll take my nice elongated green graph here and move it 2 units to the left. That is my final graph right there. So again, quick and easy, does not require the use of a graphing calculator. We're just taking a look at it. So now, I'm going to go after number 19. And in number 19, y equals a square roots of x minus h plus k. And in this one, y equals 1/2 the square root of x is going to be my parent function. That'll give me my shape. So put a 0 in there, you're still going to get 0, but put a 1 in there, and you're going to get 1/2. Put a 4 in there, 2 times 1/2 is 1. Put a 9 in there, 3 times 1/2 is 3/2, or 1.5 for graphing purposes. So this one had a positive a value. We're going to stay above the x-axis. 0, 0, 1, 1/2, 4, 1, and 9, 1 and 1/2. So there is a sketch of the curve. And now on this one we have both an h and a k, where h is negative 2, so that again is going to take us to the left. And our k value is negative 1, so we're going to go 1 unit down. So to the left and 1 down for each of the points that we just used. And that one is solid. So there's the graphing that you needed. Now I think in the review there were a couple of them that I thought you might want to see. Number 61 says, which of the absolute value inequalities has the graph shown here? Well, this is a tough process to do by taking the graph and working backwards. So what you would probably want to do instead, if you came across something like this on ACTs or MCAs, is just go ahead and set these up and solve them and see what is the solution. Because the solution we can see here is that x is between negative 2 and 4, and it includes everything in between. So that needs to be an and sandwich, and less than is going to give us an and sandwich. So these two are out. Those are both pointing to the extremes with the greater than. So for f, we'll take a look and see what we get. That would be x minus 1 sandwiched between your two escapes, which are your 3 and your negative 3. Remember, that's our prison bars. And then we'd add 1 and get the negative 2 less than or equal to x, which is less than or equal to 4. And we got lucky that f was the first one that we had to try, and it's the one that works there. Number 62 says, which polynomial cannot be factored in the real number system? Well, what I'm hoping to do is not to have to factor it, that I'm going to look at this and say, hey, I know I can't factor this one. So I look at A, maybe factorable. B, that is not factorable. We can factor a difference of 2 squares. We cannot factor a sum of 2 squares in the real number system. And if you're thinking, oh, sure we can, well, then I want you to set that equal to 0, and I want you to solve it normally. You'll get x squared equals negative 4. Take the square root of that, and there's your imaginary right there. That's going to be plus or minus 2i. 63 is talking about the domains and ranges of a couple of square root functions here. So for f of x, we want to talk about domain and range. Well, for f of x, if we put a 1 in there, we're going to get 0. So x is going to have to be greater than or equal to 1. We can't use something less than 1 or we'll get a negative, and that can't be graphed in the real number system. And then the range, well, if you put that 1 in there, you get 0. And then you think, okay, well, what happens when I put the 2 in there? Now I'm getting 1. So my values are going to be greater than or equal to 0. G of x, you can think through it the same way. And g of x is the square root of x minus 1, but without the negative 1 underneath the radical. So I think about this and I realize, okay, I can put 0 in this one. And I can put numbers that are bigger than 0 in there because that'll give me numbers in the real number system. If I put a 0 in there, I'm going to get the square root of 0 is 0, and 0 minus 1 is negative 1. If I put a 1 in there, I'm going to get the square root of 1 is 1, and 1 minus 1 is 0. So it's negative 1, 0, and then it just keeps going up. So that's going to be y is greater than or equal to negative 1. And of course you could graph it too, or you could use h and k if you memorize all of that stuff. But memorization, I'd just rather that you were able to logically think your way through these. Then number 66, we are going to find the inverse and answer the question, is it a function? So first thing you do is you change that f of x to a y, because f of x is our fancy notation for functions, but it's just output. That's all it is. So now I'm going to switch the x and the y because that is the first step in finding an inverse. And now I want to solve for y. Well, I can't gain access to that y until that squared piece is gone. So I have to take the square root. But when you draw that square root symbol on there, now you have to put that plus or minus piece in front of it. And then on the other side, we'll have 2y plus 1. So we're still solving for y. We're going to subtract 1 from both sides. And then what we need to do is go ahead and divide everything by 2. Now if we want this to look a little bit more like, our y equals mx plus b pattern, we could have plus or minus 1/2 square roots of x minus 1/2. And that one even looks a lot more like our a, h, and k pieces that we like. So probably better to go ahead and do that. Well, as we look at that, we realize, okay, this is not going to be a function. The inverse is not a function because we have the plus or minus piece. And that means one input will kick out 2 outputs. Number 69 says we've got the cubed root of x over the cubed root of 3y. If I put those together under one radical, there is nothing I can do with it. That just can't be simplified any further. So what I have to do is I have to think about how do I get rid of that radical in the denominator. Remember, to get rid of that, we need our index to match our powers. So this is a 3 to the first. I'm going to need 2 more of those 3's because when you multiply similar bases, you add the exponents. I'm also going to need a couple of y's. And whatever I do to the bottom, I have to do to the top. So now on the bottom, I'm going to have the cubed root of, in my denominator here, the cubed root of 3 cubed y cubed. And that's just going to give me 3y. Now, on the top, I have the cubed root of 3 squared is 9, and then I have an x, and I have a y squared. And that cannot be simplified. So this is done. Right there. All right. Now, and that was cubed roots, so there's no worrying about absolute value or anything like that as you're doing it. I'm going to go ahead and erase what I had for 66 so that I can make some room here for number 70. And number 70, the first thing I think of is, can I get anything simplified as it is right now? And I can't do that. So I'm going to go ahead and separate those two and try to rationalize the denominator. I cannot reduce 3 halves any more than it already is. I only have one x with a power, and I only have one y with a power. So I cannot put anything together. I can't combine anything that will make this simpler than it already is. And again, just like the other problem, our issue here is getting rid of that radical in the denominator. And I need the power to match the index. This is 2 to the first and y to the first. I'm going to need 4 more of both of those. And then my denominator will be the 5th root of 2 to the 5th y to the 5th. And those are inverses, so I'll have 2y. Now I need to go back and figure out what on earth I have up there on the top. Well, 2 to the 4th is 16, and 16 times 3 is 48, so that's going to be the 5th root of 48. I have an x cubed and a y to the 4th. And there's nothing that I can simplify in that. So there it is, 48x to the 3rd, y to the 4th. And that's going to be it for tonight's video.